Welcome back everyone. So in this video we'll be covering on the different types of liner systems and cover systems which we generally use in the construction of an engineered landfill. Now the main purpose of a liner system is to control the flow of leachate into the subsoil below. Okay, so leachate is that liquid formed out of the waste composite, and in order to prevent so this leachate would be containing many harmful contaminants or pollutants within it based on the composition of the waste that you are dumping on the landfill. So in order to prevent the leachate from flowing into the subsoil profile, we need to provide a proper liner system to the bottom as well as the sides of the landfill depending upon the profile of the landfill. So basically there are two functions which the liner system has to perform. First is to prevent the flow of leachate from migrating into the subsoil profile, and secondly it also has to make sure that the leachate which is formed within this waste composite is properly collected out of the waste composite, and then it is taken through the leachate collection and removal system to a proper treatment plant. Okay, so these are the two main functions which the liner system has to perform. So that is the reason why we will have a leachate collection and or we can call it as a leachate drainage and collection layer within the liner system, as well as we will have a part of the liner system which serves as a barrier layer. Okay, so these are the two functions which it has to serve. Now whichever liner system you choose, or whichever material you choose for constructing the liner system, it should have low permeability, it should be durable, and definitely it should be resistant to all the chemical attacks, puncture and rupture, because that liner system material is going to come in contact with several types of contaminants and pollutants. So naturally it has to be something that doesn't really react too much with the contaminants, and obviously because of the construction process that is happening over the liner system, this particular liner system should not be subjected to any puncture or rupture, because if the liner system gets ruined or a part of it gets destroyed during the construction of the landfill above, then definitely it is not going to serve the purpose for which it has been constructed. Okay, so whichever material we choose, it has to be very durable, and it should be resistant to all types of puncture, rupture, and most importantly it should be something that has very low permeability or hydraulic conductivity, so that it can prevent the migration of any such polluted solutions, or what we call as leachates. Okay, so as mentioned, the liner systems can be made either with natural materials. So mostly you will go for clayey type of soils because of its low permeability obviously, or you can make the landfill system with equivalent geosynthetic material which would perform the same function as the as its natural materials, or you can build the landfill in a combination of natural materials and geosynthetic materials. Okay, now the three main different types of liner systems are single liner system, single composite liner system, and double liner system. So let's see what a single liner system is. So liner system, it's not a single layered system. It has multiple layers within it, and each layer will have a certain function to perform. Okay. So each of these layers can be made either with a natural material, or it can be made in combination with the geosynthetic materials as well. Now in a single liner system, here these are the two different types, or these are the two different ways in which a single liner system can be constructed. Okay, so we will look at this first type of section now. So here we have the waste material which is coming above this liner system. So this full thing serves as the complete liner system, okay, over which you have your waste deposit. Now the first part that comes immediately below the waste is a protective layer. Okay, so this is kind of an extra protection that you're providing to your liner system. Okay, so that is merely for protecting the below layers from further rupture or from further, puncture or anything. Okay, then you will have your, just below the protective layer, you will have your sand or gravel layer. Okay, so it will be a combination with sand and gravel. Now the main purpose of providing sand in a liner system is to allow filtration through it. Now sand is a very great filter, natural filter. So whatever liquid that passes through the sand, it makes sure that it doesn't carry the finer particles along with the liquid, and the finer particles are completely retained within this sand filter, and only the liquid passes. Okay, so basically then this liquid will pass through the sand filter, and then it will be moving on to the drainage layer. Okay, now drainage layer, for as a natural material, we would prefer gravel as a drainage layer because it will serve the purpose. Okay, so gravel will serve the function of drainage. Now the liquid so your leachate collection systems, or in order to collect the leachate, all these pipes will be embedded within this layer, and then once the filtration filtered out leachate passes through the drainage layer, and then it will be getting collected into the respective leachate collection pipes which are embedded within this layer. Okay, and then it will be taken out of the landfill to a treatment facility. Okay, then finally what you have is the recompacted clay. Okay, so this recompacted clay here will serve the purpose of a barrier. So as I said, a liner system has two functions to serve. First function is the to collect the leachate, um, and then drain it off to a proper channel or a treatment facility, or to a treatment facility. And the second power function of the liner system is to act as a barrier. Okay, uh, so however you construct the liner system, you have to make sure that you have materials which can perform these two functions effectively. So you have the sand or gravel which can perform the function of leachate collection and drainage. Okay, whereas you have the recompacted clay which will act as the barrier layer. Okay, so this is one section of a single liner system. Now let's look at the other type of a single liner system. Now there also, just below the waste, this is your liner system which is provided. Okay, so we'll have a protective layer again as an extra cushion to the main part which serves as the liner system. You will provide a protective layer. Then below the protective layer you will have the sand and gravel layer which will facilitate the filtration and drainage function of the leachate. So there within that layer you will have your leachate collection pipes. So that will serve as the leachate collection system and drainage system. Now after that, what do you need? You need a barrier. Okay, so here instead of using a recompacted clay as a barrier, we can use the equivalent geosynthetic material, which is the geomembrane. Okay, now geomembrane, it's a polymeric material, and it will be made up of high density polyethylene. Okay, now all these geosynthetic materials are polymeric materials only. So geomembrane is one of those geosynthetic materials which is a impermeable one. Okay, so it can definitely serve the function of being a barrier layer. So instead of using recompacted clay, you can use a geomembrane as the last layer in this type of single liner system. Okay, and below that you will have your normal uh, subsoil profile. Okay, so these are the two different sections in which a single liner system can exist. Basically, it has shown one section with only natural, made up of only natural materials, and then here in the other system it has shown the incorporation of a geosynthetic material within the single liner system. Okay, so this single liner system is a very simple liner system, and as such, it doesn't offer much of a protection to the subsoil profile or your environment. So therefore, these liner systems are mostly preferred for low vulnerability landfills. That is, landfills which are not susceptible to much of a contamination to environment. Okay, or which doesn't produce, more contaminated leachates. For such type of landfills or for such low vulnerability landfills only, we'll go for a single liner system. Okay, now let's move on to the next type of liner system. So next is a single composite liner system. Now here, so let's look at the first type of a single composite liner system. So here you have the waste. So this is the entire, below the waste, this is the entire liner system that we are going to talk about, the single composite liner system. So here, what you have is, you have the protective layer, which serves an extra cushion, okay, for the liner system below. Then below the protective layer, you have a geotextile layer, and then you have a sand or gravel layer. So basically, if the geotextile is kept, obviously the geotextile will, geotextiles are of different types. It can be of woven or non-woven type. In woven type, you will use the polymeric materials and do the weaving process, like the usual weaving process of polymeric materials. Whereas in non-woven, it is like, you just put some put the fibers randomly and then make them join together by some means of bonding. Okay, it can be chemical bonding by means of adhesives. So there is non-woven and woven type. So mostly we would prefer woven geotextiles as a filtration layer, because compared to a non-woven, a woven geotextile would serve the function of filtration better. Okay, so geotextile here can serve the function of filtration. So once you filtered out water, then next stage is to drain off that water. So you can use a gravel layer. Okay, and then gravel layer is provided for the drainage. So obviously you will have your leachate collection pipes embedded within this layer. Okay, and the leachate collection pipes will take off that filtered out leachate, and it will be taken out of the landfill system. Then what you have is a geomembrane layer. Okay, so again, geomembrane is a non-permeable barrier material made of polymers, which can be used as a barrier in your liner system. And here there is recompacted clay as well. Okay, so here basically this single composite liner system has been given two barriers itself. Okay, even if you look at this one section, there are two barriers, there are two materials which serves the function of being a barrier itself. You have clay as well as geomembrane here to serve the function of being a barrier. So there is always an extra safety here. Okay, now let's look at the other type. Now the other type is that, where you have your waste, and this is your entire single composite liner system. So here, you will have your protective layer, then you will have your geotextile, which will serve the function of filtration. Then you will have your gravel layer, which will drain off the water. Then geonet also is one of the polymeric materials or geosynthetic materials which can serve the function of drainage. That is same as gravel. It is equivalent to the function served by gravel. Okay, and then again you have geomembrane and recompacted clay. So basically you have two barrier materials. Okay, that is a geosynthetic material as well as a natural material which will perform the function of barrier. So there is an extra safety. So this forms the composite liner system. Okay, so when you draw, actually you can draw one section completely with natural materials except for this part. Okay, so the difference between single composite liner system and single liner system is that In composite liner systems, you will have two barrier materials at the at the bottom of the liner system. Okay, so when you draw one of these sections, you can show it like, waste, below that protective layer, below that you just show the sand or gravel layer, and below that you can show the geomembrane plus the recompacted clay. Because it's a composite liner system, it is using two barrier materials. Okay, then in the next section, what you can show is below the waste, the protective layer, then you can make this entirely with your geotextile. Okay, you can show the geotextile layer, then geonet, then finally geomembrane and recompacted clay as the barrier system. Okay, that way also you can show. But in both sections, make sure that you show two barrier materials, one a polymeric material and a natural material which is used as a collective barrier system. Okay, that is the only thing. So this single composite liner system is actually the minimum requirement for a liner system which is to be provided for a municipal solid waste landfill. Okay, so we have already seen what are the contents of a municipal solid waste landfill, and obviously due to some materials there will be some pollutants coming out with the leachate. So instead of providing a single liner system which is very too simple and not that safe, it is always good to provide a single composite liner for municipal solid waste landfill. Okay, so at least this is the minimum requirement of a liner system for a municipal solid waste landfill. Okay, now let's move on to the third type of liner system. Now third type of liner system means it is called as a double liner system. So just imagine when it says double liner system, just imagine it as a combination of two composite liner systems. Okay, so this double liner system, just think of it as a combination of two composite liner systems. So let's look at one of these sections. You have waste, below that you have your entire liner system. Okay, so just below your waste you have your protective layer, which is an extra cushion. Then comes your filtration layer, which can be geotextile or sand. Then comes your drainage layer, which can be your gravel or geonet layer. Okay, then within this layer, obviously your leachate collection pipes will be embedded, and leachate will be collected and taken out of the landfill. Then what you have is a combination of, once the leachate collection and drainage function is served, the next function the liner system has to serve is the barrier function. So for the barrier function, here in double liner system also you have two barrier materials. One is a geomembrane and other is a recompacted clay. Okay. Now again, if this this composite liner also is not able to serve its function of being a barrier very effectively, and some sort of leakage happens, then as a leak detection layer or as an extra protection, we have another filtration and drainage layer here. Okay, and then you have your geomembrane and recompacted clay. Okay, so the basic components of a liner system are, you will have a leachate collection and drainage system, and then you have a barrier system. Okay, so in double liner systems are made up of two such combinations. Okay, that is, it will have two leachate collection and drainage systems, and it will have two barrier systems. Okay, and in the barrier system it will be a combination of a geosynthetic material as well as a natural material. Okay, so as I said, a double liner system can be imagined as a combination of two single composite liner systems. Okay, so that extra system of leachate collection and drainage as well as barrier system is serving as a leak detection layer. Okay, so even if something happens to the that is, even if something happens to this above liner system, okay, this much, the remaining part can take care of the functions which the liner has to perform. That is the idea behind double liner system. Okay, so this is an extra protective liner system, and it does take care of the leakages that can possibly happen while passing through the first layer of liner system. Okay, so that is why these type of double liner systems are preferred and should be made for hazardous waste landfills. Okay, so for hazardous waste landfills or landfills containing highly toxic materials, double liner system is a must. Okay, so generally these are the three types of liner systems. So as an overview, these are the different liner components that come within the liner system. So, it can be a composite clay liner. So generally a liner system will have two separate systems, that is a leachate collection and drainage system and a barrier system. Okay. So for a leachate collection and drainage system, you can use basically the leachate collection drainage system has to perform the function of filtration as well as drainage. Okay, so if you are opting for natural materials, you can go for sand for serving the filtration function, and then you can go for gravels which can serve the function of drainage. Okay, so the finer particles will be retained within the sand layer, and only the water will or the liquid will pass through the sand. And then we have to make sure that proper drainage is happening within the drainage layer, which can be made with natural materials like gravels. Okay, and usual thickness of such drainage layers are 30 centimeter thick, and the permeability should be greater than 10 raised to minus 2 centimeter per second. Okay, now one of the issues that we normally face when we are going for natural materials to be used as leachate collection and drainage system is that after some point of time the sand will get clogged. Okay, so the main thing is that we are retaining the finer particles so that there is no clogging happening in the drainage layer. Okay, there is a smooth drainage happening. But what happens is that after a certain amount of time, the effectiveness of sand as a filter will reduce, and there will be clogging of finer particles within the sand layer. So you will not get effective filtration, and thereby your drainage will also get affected. Okay, so that defect can be overcome by the use of equivalent geosynthetic materials which can serve the function of filtration and drainage. So you can use geotextiles instead of sand. Okay, it is polymeric material. Then you can use geonet instead of gravel, which will serve the function of drainage. Okay, so it is also a polymeric material. Now, as a barrier system, what we normally use is the clay liner. Okay, you will have the composite clay liner, that is a compacted clay liner. Okay, and if you are using a pure clay as a liner system or as a barrier system within the liner system, then the normal thickness of these compacted clay liners will be varying from 0.3 to 1 meter. Okay, and the permeability factor is very important because you don't want the permeability to be high. You want to keep the permeability to be less than 10 raised to minus 7 centimeter per second. Okay, this is the requirement if you are using a clay material as the liner system. And one of the issues, since this is a natural material and it's a clay type of soil, it will definitely be susceptible to changes in the freeze thawing cycle. Okay, so but this can be overcome by using equivalent geosynthetic materials, or you can use this clay in combination with geosynthetic materials like geomembranes, as we saw in composite liner system. So geomembranes also polymeric materials and mostly can be made with PVC or high density polyethylene, but mostly we would prefer the high density polyethylene because it is more impermeable and more resistant to these chemicals and rupture. So geomembranes are also called as flexible membrane liners, and the minimum thickness that you have to keep is 1.5 mm. Okay. So So the barrier system, either you can use just the compacted clay liner, or you can use it in combination with the geomembranes or the which is the geosynthetic material. Okay. Then another type of barrier system which you can use is the geosynthetic clay liner. Now here, what is the geosynthetic clay liner is that it will have a clay material sandwiched between two geotextiles. Okay, so and this clay material will be mostly made with bentonite clay. So the property of the bentonite clay is that as soon as it comes in contact with a solution or water, it swells up and becomes highly impermeable. Okay, to the further coming liquids. So geosynthetic clay liners are also widely used now as the barrier system within the liner systems. Okay, so these are in general, and one of the advantage of one of the advantage of going for a geosynthetic material as a uh, barrier layer is that it will not be susceptible to your usual freezing thawing cycles or other climatic changes, and also it will not be you can rapidly install these geomembranes because these are sheets. Okay, so you can just rapidly install them, whereas in order to make a composite clay liner or a compacted clay liner, layer by layer you have to put in the clay soil, you have to compact it, you have to make sure that it is not open to atmosphere as such, so you have to keep spraying some moisture to it so that it doesn't dry out. So all such practical problems will be there with the use of compacted clay material only. But if you are going for geomembranes as the barrier, it is rapid installation plus no effect of climates. Okay, so these are the different liner components. Now we will move on to our cover system. So before moving on to cover system, actually let's look at the pictures of the geosynthetic materials. These are geomembranes, and as you can see, these are just sheets laid out. Actually all these materials will come in rolls. Okay, so at site you just need to uh, lay out these in the field, then stitch the different sheets together. Okay, so installation process is very easy and quick. So these are geomembrane layers, completely impermeable, and these are geotextiles, and the first picture is a woven and this is the non-woven. So woven, you can see the weaving pattern here, and in non-woven you will not see any such pattern because it is just random fibers distributed and then some chemical bonding or mechanical bonding which has happened. Okay, for binding them together. Then you have a geonet which serves as the drainage function. Now let's look at the components of a traditional cover system. Okay, so the cover system is the ultimate component that comes on your landfill. So once a landfill is completely, obviously you will have intermediate cover systems and daily covers which is coming during the construction time. But once the complete construction of the landfill is done, you will provide a final cover system. Okay, and that will include the following components. Now the first thing that you will see is that vegetation. Okay, so when you provide vegetation, make sure that you don't provide deeply rooted plants. You only need to provide shallow rooted plants. Okay, because you don't want it to interfere with the rest of the system. And whatever vegetation you provide, that is a self-maintaining type. I mean something which can survive on low nutrients as well, because obviously this is coming on top of the waste, so you cannot expect much nutrients to come to the plants. So so whatever plants you choose, it should be something that can survive on low nutrients, that can survive in some arid climates as well. Okay, and obviously when you give the vegetation, the advantage is that it can prevent the erosion, and it can also increase the evapotranspiration, thereby preventing infiltration of water into your um, underlying layers. Okay, so you don't want any water to infiltrate through the cover system and into your waste material, because as we have learned that any extra water, any excess water can only increase the quantity of the leachate which is generated, and you don't want that. Okay, so just below the vegetation, what you have is a topsoil. So obviously this will support the vegetation which is coming over it, and that is the purpose of the topsoil. It will be some 60 centimeter, and then it will also be made up of some natural soil, cobbles, other natural soil, gravels, etc. Then you have protection layer which will be of 90 centimeter. Actually the 60 centimeter is for the topsoil. Okay, topsoil thickness will be sorry, one second. Topsoil thickness will be 60 centimeter. Protection layer thickness will be 90 centimeter actually, and this may or may not be present. Okay, in some cover systems it may not be present. So if it is present, 90 centimeter can be given as a protection layer, and it can also be made with cobbles and gravels. Okay, and it will also you know uh, even if some burrowing happens, this can act as an extra cushion to your cover system. Burrowing by rodents and all happens, this can act as an extra cushion system. Okay, then comes the main function of your filtration, drainage, collection, and then finally barrier. This is how the normal functions are carried out within the cover system as well as in the liner system. So just after the protection layer, you will have a filtration layer. Now filtration layer can be made with sand or the equivalent geosynthetic material. So it can be 30 centimeter thick. Okay, filtration can be 30 centimeter thick. Again, you will have your gravel or either your geonet layer which can serve as a drainage function. This can also be 30 centimeter thick or 60 centimeter thick. Now all your leachate all your collection pipes will be embedded in this layer, so that you don't allow any sort of water to like pound water to get collected over the geomembrane layer. Okay, so before any collection of water happens over the geomembrane layer, these pipes can collect the water which has been filtered out and drained out through the drainage layer, and it will be taken out. Then after the drainage layer, you will have your geomembrane layer. Again, the minimum thickness of geomembrane, okay, in which it is available, can be provided. Then after the geomembrane layer, you will have your soil barrier layer. Okay, so this is like a composite liner which is provided here. You have geomembrane plus the natural soil which can also act as a barrier. Okay, so here it is written geomembrane overlying protective with overlying protective geotextile. That is, sometimes in order to prevent the geomembrane from getting ruptured or from getting damaged, what we do is we normally lay non-woven geotextiles over the geomembrane. Okay, so that non-woven geotextile will act as a cushion for this geomembrane. So this geomembrane is protected from all sorts of rupture and damage. Okay. Then, so this is a composite liner system, that is with the geomembrane and the natural soil as a barrier. Then after that, as a final layer, what you have is a geotextile gas collection layer. This is a gas vent layer. That is, if the waste produces toxic gases, you need to collect those gases and vent it out properly. For that, you will have any natural material like sand, and sand also you can use it as a gas vent layer, or otherwise you can use geotextile as a gas collection layer and vent out these gases properly. So these are the typical components of a cover system. Okay, so that's all with our liner systems and cover systems, and next we will look in detail about the compacted clay liners in our next video. So thank you all.